Hi everyone and welcome to another YouTube video. In today's video I'll be trying to dive more into the world of discrete probabilistic distribution. I won't still start the calculation aspects per se, but I will try to explain how the probabilistic value of each of these random variables of an experiment actually interact with each other. We'll also talk about how we can visualize the probabilistic value and the random variable of a discrete probabilistic distribution. So without further ado, let's actually jump into the video and start learning properly. In the last video, I've actually explained what a discrete probabilistic distribution is. I actually gave examples and the necessary details we actually need to know about this. So if you actually want to watch that video, I'll be linking it in the top right corner so you can just go check that out. So to explain the basic concept of discrete probabilistic distribution, I would be using an example of my friend who is a caterer and he also sells pastries. So his name is Billy, and he realizes that once he have data about his business, he can be able to make some conclusions and have more sales in the long run. So Billy decided to collect data for 1 week on the number of cakes he actually sells in a day. So we have 7 days of the week, and we have the number of cakes he actually sells on each day of the week, and this is what the data that Billy collected looks like. As you can see, we have the number of days. We have day 1, we have day 2, we have day 3 down to day 7, and we have the number of cakes that he sells on each day, which is actually the random variable that we are actually interested in. Please note that the random variable is usually denoted with an uppercase X, and the probabilistic value attached to any random variable is denoted as P into brackets X is equals to X, where the uppercase X represents the random variable and the lowercase x represents the value of the random variable. So we can see that from our table, we have that in day 1 it sells 10 cakes, in day 2 it sells 15 cakes, in day 3 it sells 20 cakes, down to day 17 which it sells 15 cakes. If we decide to sum all of the number of cakes he sells in 1 week, we can see that he has sold a total of 100 cakes. Now the next step is for us to try to get the probabilistic value attached to each of the random variable. That is, what is the chance that he's going to sell a cake in day 1, a cake in day 2, down to day 7. And if you can recall from our probabilistic class, we said that probability that an event A is going to occur is actually equals the number of outcomes that favors event A divided by the total number of possible outcomes. So for day 1, the number of cakes sold in day 1 is actually equals to 10, and we have a total of 100 cakes. So the probability of him selling a cake in day 1 is going to be equals to 10 over 100, and that gives us 0.1. In day 2, we can realize that it sells 15 cakes and the total number of cakes is equals to 100. So the probability of him selling a cake in day 2 is actually equals to 15 over 100, which is equals to 0.15. We do the same for day 3, day 4, down to day 7. We have a complete table that shows us the days, the number of cakes being sold in a day, and the probabilistic value of selling a cake in each day. This table of R simply means that the probability of selling a cake in day 1 is actually equals to 0.1, probability of selling a cake in day 2 is actually equals to 0.15, probability of selling a cake in day 3 is equals to 0.20, and so much more. So what if I decide to tweak this question a bit and try to get more detailed information, like what is the probability that X is actually greater than or equals to 3? This translates to the fact that what is the probability that is going to sell cake from the day 3 down to day 7. This simply means probability that X is greater than or equals to 3 is equals to probability that X is equals to 3 plus probability that X is equals to 4 plus probability that X is equals to 5 down to probability that X is equals to 7. And when we do the math, we have the probability that X is greater than or equals to 3 is equals to 0.20 plus 0.05 plus 0.15 plus 0.10 plus 0.15, and this gives us 0.65. We can also ask the question that what is the probability that X is actually greater than 4, which translates to what is the probability that is going to be selling cake starting from the 5th day, because we are not adding equality sign to the greater than sign. So that is probability that X is equals to 5 plus probability that X is equals to 6 plus probability that X is equals to 7. And when we do the math, we have 0.15 plus 0.10 plus 0.15, and that gives us 0.40. So the probability that X is greater than 4, which is probability that is going to sell cake from the 5th day down to the 7th day, is actually equals to 0.40. So summing probabilistic value of each of the random variables like this is what we call the concept of cumulative probabilities. So we can also try to like perform a bit of mathematics and algebra on some of this probabilistic value. Let's go back to the example of probability that x is actually greater than or equals to 3. We know that probability that x is greater than or equals to 3 is equals to 0.20 plus 0.05 plus 0.15 plus 0.10 plus 0.15, and that gives us 0.65. Now, one thing we need to know is that the sum of all the probabilistic value of the number of cupcakes being sold in a day must be equals to 1. So we are interested in probability that x is greater than or equals to 3. This can also be written as 1 minus probability that x is lesser than or equals to 2. So that means that summing from 3 to 7 is the same thing as saying 1 minus summing from 1 down to 2. This rule is actually what we call the complement rule. We can also use this idea to solve the question that probability that x is greater than or equals to 4. So probability that x is greater than or equals to 4 is equals to probability of x equals to 4 plus x equals to 5 plus x equals to 6 plus x equals to 7. That is, we are summing from 4 to 7. But this can also be written as 1 minus probability of x is equals to 1 plus x is equals to 2 plus x equals to 3. That is, probability that x is greater than or equals to 4 is equals to 1 minus probability that x is actually lesser than or equals to 3. We can also visualize our discrete probabilistic distribution. Our discrete probabilistic distribution is actually countable, and one of the best tools or the best tools to actually visualize a discrete random variable is actually a bar chart. So on the x-axis you have the random variable you are working on, and on the y-axis we actually have the probabilistic value. So if you are supposed to plot a bar chart for the data sets that Billy collected over the week for his business, we are going to be having something of this nature, and it shows that in day 1, which he sold 10 cakes, he has a 0.1 chance of selling a cake, and in day 2, which he sold 15 cakes, he has a 0.15 chance of selling a cake, and so much more. And this is the basic idea behind the probabilistic values of a discrete probabilistic distribution interacting with each other. In the next video, I'll be teaching us how to get the expected value, the variance, and the standard deviation of a discrete probabilistic distribution. If you enjoyed this video and you actually learned something new from this video, I would really appreciate if you can give this video a thumbs up and also subscribe to this YouTube channel. Did I miss anything and do you have a question? Go down to the comment section and let me know about them. Thanks for making it to the end of this video, and we see you in the next one. Bye for now.